Hello there, Mr. Chan for Algebra 2. Grab your note takers. We are going to start 5-6, inverse relations and functions. Turn to page 135 and let's get started. All right. Explore and reason. Each number path will lead you from a number in the domain, the set of all real numbers, to a number in the range. Here's a path right here. Number path from x to f of x, and another set of directions, g, going from x to g of x. So we have two functions here. They want us to try to follow directions. When it comes to following directions, don't forget about your order of operations. That's kind of important here in a moment. Let's take a look at the first one. Follow the number paths to find f of 1. Let's do that first. This is function notation, meaning you are inputting x with the number 1. Okay? Here it is. Let's find it. Start with the number x. Okay. In our case, x is 1. Next step, subtract 3. Okay. Subtract 3. Very good. Then multiply by -2. Notice I parenthesized the 1 minus 3 to force it to be done first. Next, I'm going to multiply by -2. Fine. And then finally, it says add 5. So I'm writing it out to show the order of operations is important. So if you do the math here, 1 minus 3, of course, is -2. Bring everything else down here. -2 times -2 is +4. 4 plus 5 is 9. And there's my answer. When you plug in the number 1 in this path, I get the answer of 9. Great. We'll hold on to that for a moment. Let's check out the other number path. We're going to do g of 1 in the function. All right, start with x. In this case, it's 1. Great. Add 1 this time. Fine. Next, go ahead and square the value. Interesting. Then subtract 2 at the end. Okay. Let's do the order of operations here. 1 plus 1 is 2. Great. 2 squared is 4. Awesome. 4 minus 2 is 2. So g of 1 is 2. Very good. So we're just following directions here and getting answers. Let's see what else they want us to explore here. Identify all possible values of x such that lead to f of x equals 7 and all values that lead to g of x equals 7. Oh, this is a different question in a weird way. So we just follow directions using PEMDAS. Here, they're asking us to figure out what x is this time, not the y value, but x. Here we have to go backwards. They tell us what the final answers are. For the first function, it's 7. How do we get to 7? What x value will lead us to the number 7 for both of those functions? That's the question here. Okay? We're going to work backwards to get to those spots. So we know from the first part, f of x equals 7. We got to work backwards. You guys doing okay out there? All right, sounds good. F of x, in this case, think of it as the letter y. All right, from above, and you may not be able to see it right now. Let me scooch on up a little bit. Oh, let's go backwards of this particular path right now. Instead of adding 5, I'm going to go ahead and subtract 5. Subtract is the inverse of adding. Let's go backwards again. The next step that I have to go backwards with is opposite of multiply by -2. Hey, let's go ahead and divide by -2. Boom. And then from there, we need to go backwards of subtracting 3 next, and that would be adding 3. Notice my liberal use of parentheses. So let's see what happens when we simplify this particular problem, applying each of the inverse of those operations, okay? So 7 minus 5 on top is, of course, 2. 2 divided by -2 is -1. -1 plus 3 is 2. There it is. The x value of 2 will give me a y value of 7. That solves that mystery, doesn't it? Let's work backwards so g of x equals 7. All right, let's take a look at the instructions. Let's go ahead and go backwards of subtracting 2. Let's add 2 to both to the 7. Great. I'm looking at these directions right here right now. I'm going backwards. Instead of squaring the value, we need to square root the value next. Now, recall, when you square root, you do have to introduce a plus or minus. There are 2 answers that will give you that answer going the other way. Then we need to do the opposite of add 1. We need to subtract 1. So there's our setup right there. It's a little more complicated with that plus or minus, isn't it? Inside the parentheses, 7 plus 2 is 9. Great. Square root of 9 is 3. Nice. Ooh, we have 2 paths here. Positive 3 minus 1 is 2. Negative 3 minus 1 is -4. Ladies and gentlemen, we have 2 answers for x. That leads us to that y value of 7. Ding, 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 ding. This is considered to have 2 solutions. Very interesting. All right. Habits of mind at the bottom is kind of interesting. Write a rule for a number path f. Write a rule for the process of following the number path backwards. How do the 2 rules compare? So instead of just using the number 1 that we started out with this opener, let's just use the variable x instead of 1. The first rule was to subtract 3. Okay, x minus 3. The next step was to multiply by -2. Fine. There's that. And the last step is to add 5. And ladies and gentlemen, there it is. That -2 can be written in the front, so that's allowed. It makes it a little more nicer looking. Okay? Either one of those are correct. Let's go and figure this out backwards. Again, we're just going to, whoops, that was weird. Bath. So going backwards, the function, we just go backwards. We literally take the function f of x and go backwards of -5, add 5. Opposite multiply by -2, divide by -2, and then finally backwards of -3 is add 3. And there's your path backwards. Okay, let's try the next page. So guess what? This section is all about functions and their inverses. Something unique happens when you look at a function. Let's redefine this and remind ourselves what function means. A function is where every x value has a unique y value. You can also use the vertical line test to check this out. The vertical line test states that no matter what line you draw through a function, you only hit it once. If you hit it more than once, then it's no longer a function. It's called the vertical line test. Now, what does it mean for inverse? Inverse of a function is where you swap the domain and range. The x's become y, and the y's become x's. That's what we're doing there. So for our opener here, we're given a table. Keep in mind the definition of a function. For every x value, there's a unique y value. Identify the inverse relation. So what we're going to do is we're going to swap the x's and the y's in this table. There are 6 pairs of numbers, fine. I'm just going to go ahead and swap the x's and the y's. Here we go. There's my inverse. Question, is it a function? Let's check. Does every x value have a unique y value? 9 goes to -1, 7 goes to 0. Yeah, I'm taking a look at my x's here. There's no repeated x's. So every one of those x's has a unique y value. This is true. Every x value goes to a unique y value. This is true, which means the inverse of the function is a function. Meaning there are situations where that is not true. Keep that in mind. It is a function. For number 1. Yay. That was just a table. Question. How does one find an inverse? That's the next question on our notes here. How do we find the inverse? All right. Here are their steps to find an inverse. The key is to swap x and y algebraically. Aren't we swapping the domain and range up there? Next, isolate your variable y. And that's it. That's how you find that equation algebraically. Let's take a look at our opener here. We have a function f of x equals to 2x plus 1. Remember, f of x is literally the letter y. Okay? And I want to show you, it's just a simple, very simple graph of an equation of a line. Here I'm switching over to Desmos, and you can see y equals 2x plus 1 is just a simple line there. Yay. In a moment, after we find the inverse, I will show you what will happen when we graph it. All right. So the rule is to swap x and y. Let's do that. Literally swap it. And isolate y. Because they're asking us to write an equation to represent the inverse of f. All right, so step 1's already done. I switched to x and the y. I'm now going to move everything away from y. So I have a 2 in front of it, multiplication, and a plus 1. So opposite of opposite of PEMDAS is SADMEP. I'm going to go ahead and subtract 1 to both sides. That gives me 2y equals x minus 1, then divide by 2. Yay! My inverse is x minus 1 over 2 equals y. Now I'm going to put it in mx plus b form to make it look nicer. And this is going to be, and I split that up over 2, 1/2 x minus 1/2. half. Ladies and gentlemen, there's my inverse. Now, I don't know if it's a function or not. There's no guarantee if that function is an inverse or not, okay? So I've already inputted that into Desmos. Let's take a look at that. There it is. Oh, that's kind of interesting. Kind of take a look at this, tilt your head a little bit, and you notice that it's a mirror image along the y equals x line. Now, y equals x is like this. Follow my mouse here. It says diagonal. So this is a revelation now. The inverse of functions do a reflection about the y equals x line. It's a mirror image. All the x's become y and all the y's become x's. Makes sense, right? We're swapping literally all the x's and the y values. Makes sense? So that's something interesting that we're going to explore a little more with some other examples. So in fact, I'm going to graph them right now on this page. All right, very good. So the first one, I'll just use green to make life easier for myself. It has a y-intercept of 1, has a slope of 2, fine. Connect the dots. That's the original 2x plus 1. I'll call it f of x. The other one, I'll use red. Ooh, that's a weird y-intercept. Negative 1/2 is the y-intercept. Its slope is 1/2. Connect those dots. Ooh, interesting. And those two functions are a mirror image along the y equals x line. Just going to throw that in. Excuse me, I have major allergies this morning. That's how they're related. All the x's are y's and all the y's are x's between the two functions. Now, this is technically called the inverse of f of x. I want to teach you guys something new. The notation for this, also known as f to the negative 1 of x. Please note, this notation here doesn't mean you reciprocate. It's just inverse. That's all. It's bad notation that I've never liked at all. This means inverse. Okay, it doesn't mean to reciprocate, which what it would be if it was an exponent power, but this is not an exponent power. It's just a funny notation. Okay, this means a couple of things. Please note. The inverse of a function is not necessarily a function itself. There's no guarantee. Just because it starts with the letter f doesn't mean it's a function. F is just an arbitrary letter. The inverse of a function could fail the vertical line test, so keep that in mind. Another thing to keep in mind, that notation is strange. F inverse of x does not mean 1 over f of x. Okay? So these are some major things I ran across as a student that I got confused with over the years, and now I'm a little bit better as a teacher, so I can pass that along to you guys. Take note of those two things. Thank you very much. The habits of mind talks about the number path, of which we just did our problem. If we were to go backwards of this function to find the inverse, of course, we want to subtract 1, right? That's opposite of plus 1. And then, of course, we want to divide by 2, which is opposite of the multiplication by 2 right there. We're just going backwards. Yay. You guys ready for example 3? There's not a lot of room here, so I apologize for example 3. Let's go off to far left here to do example 3. We're given a couple of functions. They're different parent functions here. We have a quadratic, and we have another quadratic. It looks like a difference of squares right there. Find the inverse of each function by identifying an appropriate restriction on its domain. Now, this is a situation where the inverse is going to produce something where it's going to cause a little bit of a headache when it comes to defining it as a function, okay? All right, so first off, I'm going to go ahead and graph on Desmos 3a to just show you what it looks like and remind you what that is from the past. X squared plus 8x plus 16 is definitely a parabola, as you can see. Visualize that parabola flipped along the diagonal y equals x, as if you're folding this piece of paper along which my mouse is moving right now, okay? If we folded it over like a butterfly, right, what would it look like? That's the question. Let's go back and do this algebraically. All right, so step 1. Swap x and y. Oh, where's y? Oh, it's right here. So swap x and y, the actual variables. This is the weird part. I realize x shows up in more than one spot. And when I swap x and y, my equation becomes x equals y squared plus 8y plus 16. This is a very unusual problem. I realize that if I try to factor this or use a quadratic formula, it's going to turn out ugly unless something specific happens. This particular quadratic they give us is actually a PST, a perfect square trinomial. It's actually factorable. Crazy. If anything else, it would not be factorable if it wasn't a perfect square trinomial. Because when you factor a perfect square trinomial, it becomes y plus 4 times y plus 4, or simply y plus 4 squared. So that's an unusual situation where it does work out nicely. Oh, now the key is to isolate y. Remember, step 2 of finding inverses. Swap x and y that we did earlier. And now we're asked to isolate y. And you know this graph is a parabola. Just to remind you of that for your notes. So when we try to isolate y here, we need to do undo operations with the square. Opposite of square is square root, both sides. Interesting. Now I'm going to put the plus or minus on the other side. My bad. Meant to put it over there. That was an accident. When you square root, the square root cancel each other out on the right side. This gives me now plus minus x equals y plus 4. Let's move the 4 to the other side by subtracting. This will now give me y equals 2 equations. They are negative 4 plus minus root x. This is considered 2 equations now. Keep that in mind. Now here's the challenge. This particular inverse is not a function. Think about the parabola flipped and rotated, right? It will fail the vertical line test. So here, what you want to do is look at only 1/2 of it. This is actually something that we look at when going into trigonometry and calculus. In order for us to do more algebra and to consider the function, we only look at the top half only. So here, I only want to focus on the top half, which is negative 4 plus root x. You'll see in a moment what that's going to look like. So hang tight for a second. Let's go to Desmos and see what I mean by top half. There it is. If I drew the bottom half of the parabola, it will no longer be a function. I only need the top half. It'll become clear as you go on into trigonometry why we only need the top half when it comes to functions. Okay? Trust me for now. So here's the thing. I know I just jumped back to my notes here. How do I describe this top half is the question, okay? Relative to my original problem, x squared plus 8x plus 16. How do I force it is the question. So hang tight here. I'm going to show you how that's done. I'm going to mimic the graph here off to the left, what we saw under Desmos. We have a parabola from my original function, f of x. The graph that I just got is a mirror image of the y equals x line. The graph that we just did, oh wait, I just realized something. Sorry about that. My parabola is a little bit off. Lo siento. It's over here. My apologies. That point right there, the vertex, I don't know if you caught that under Desmos, bottoms out at -4 for x. Sorry about that. The graph through which the inverse starts at is at -4 on the y-axis. And it goes upward like this. This is the inverse. I've not drawn the bottom half, otherwise it's no longer a function. Now, how the heck do I describe the original? I need to put something called a restriction on the domain. This bottom half, I'm sorry, this top half, I meant to say, with the inverse, is a mirror image of this guy right here. This is the right half of the original function. So this is what they want, ladies and gentlemen. I need to describe the function f of x with a restriction. So when I graph the inverse of the original function, it's a function itself. I only want half of it. Okay, how do I go from here to here with that restriction? So this is what I do. You write down the parabola from earlier and say this. The domain is this piece right here only. I can't graph this side. That's illegal. So how do I describe it as an inequality? Well, look at the x value. I can only start at -4. X -4 to the right. This is called a restriction. A function with a restriction on the domain, which will allow me to graph the inverse of the function and make it a function itself, the top half of that parabola. Okay? It's kind of weird. I know this is a lot to absorb. Ask me in class if you have more questions about that. Okay? We're going to do the same exact thing with the second problem. Happens to be a parabola as well. Let's go through the motions and I'll show you what it looks like in a moment. This is y, of course. Swap x and y. And let's come up with a function here. X equals to y squared minus 9. And isolate y. Add 9 to both sides. We now have y squared equals to x plus 9. And then we need to square root both sides. It does produce a plus or minus again. And our function now is y equals to plus or minus the square root of x plus 9. Now, which half do we need is the question, right? Kind of like the other side. We only need the top half. Forgot to mention that here from earlier. Here on this side, let's kind of visualize what this graph looks like. This is a crazy one. The original function is a parabola that's been shifted down to 9, like this. That's your original function. When I mirror image this, and I need to decide what to do with these two halves, I only need the top part of it. So I got to say this. Y equals the positive x square root of x plus 9 is the top half I need. There it is. And that top half, ladies and gentlemen, I believe looks like this on this graph. I'll show you that. That's that part right there. Okay, let's check that out with decimals. My memory is a little iffy. Turn that off. There's that one. Zoom out. And there it is, the other half. Yay. Very good. I only need the top half. I don't want the bottom half because otherwise it would fail the vertical line test and it will no longer be considered a function itself. And I think I forgot to put in the restriction for the second half under the notes. Yeah, I did, didn't I? Whoops. So my restriction should be f of x is equal to x squared minus 9. And my restriction is for the domain is my x value must be, and let's just double check, make sure you guys are wondering. Oh, you guys see right there? Yeah. And it's going to be positive. Oh, wait a second. That top half is a mirror image of this guy right here. Yeah, to the right of 0. So wanted to double check, folks. X is greater than or equal to 0, meaning this piece will produce this piece right there, okay, to the right of 0. And there's my restriction. Yay. Must have forgot that in my notes last year. Whoops. Need to fix that one, don't I? All right, you guys ready for the next page? Keep in mind, this part right here was not a function. I can mention that, sorry. We had to restrict it. Okay. Next page. We're getting to some interesting looking functions here. That's a pretty wacky one. Number 4, let f of x equals to 2 minus the cube root of x plus 1 underneath the radical. This is just a cube root function. In fact, they've written it kind of weird. Cube root functions transformation form looks like this. Looks like they move the k to the front, that's 2, and your a value is -1, kind of interesting. That's a vertical reflection. And that 2, of course, is your k value, meaning goes up. Interesting. Let's draw some axes here. All right, this is going to be a very unusual function here. We have a two-parter. Not only do we have to graph it, the function itself, we also have to verify the inverse will be a function and write it as a function from the original, okay? I'm actually going to do both, but the word verify is very important. It's kind of weird. Understand that a function and its inverse are related early on when we swap the domain and range, meaning we exchange x's and y's, and we literally, when we graph them, the functions are a mirror image along the equation y equals x, a diagonal line. In fact, we're actually going to pull in some other technique to use from the previous section to help verify. How do we verify whether or not two functions are inverses of one another? We're actually going to pull up composition of functions. Fogg and Goff to help with this process. Remember those guys? All right. Here's the check. If Fogg of x, remember putting G into F, is equal to Goff of x equals to x, meaning you get this expression at the end, then F of x and G of x are inverses of one another. That's the verification. That's the checker. Okay? We'll hold off on that in a moment. When we sketch 2 minus the cube root of x plus 1, we are taking the cube root function, as you know from before. The graph looks like this. We're going to shift it, looks like up to, and looks like when h is -1, that means I'm going to the left. So this graph is going to look kind of funny. So let's do this. Oh, and there's a reflection too. Oh my goodness. So I'm going to go ahead and reflect this graph. And when I do that, it's going to go like this. So I did the reflection first to make life easier, okay? And now I'm going to shift those 3 dots. 1 left, 2 up. 1 left and 2 up. Great. And there it is. The mirror image of this, or the inverse, and they don't ask us to do it, we're going to do it just for fun, should be a mirror image along this dashed orange line. Those 3 blue dots for the original function, those x values should be swapped with the y value. So that first dot on the left is -2, 3 goes to 3, -2. Very cool. The second one is -1, 2. That becomes 2, -1. Awesome. And the third one, 0, 1, goes to 1, 0. Awesome. So forgive me. I'm going to try to do my best here. I'm going to try to draw this. Wow, that's a crazy graph. And ladies and gentlemen, that is your inverse. Using no calculators, but it's really cool that that worked. Let me show you that on decimals. There's my original. Very good. And there's my inverse. Theirs is more correct, of course. The most correct in mine is not as curvy as theirs. But there it is. Very cool looking. There's mine. So that's the graphical portion of showing a function and its inverse. Very cool. That's one of my favorite types of inverses. Very cool to see the curves. Verify. We need to check Fogg and Goff. That's the checker, right? Okay, here we go. Oh, we totally forgot to actually find the function itself. Let's swap x and y. We've got to find the inverse, okay? All right. Swap x and y. Let's do that right now. X equals 2 minus the cube root of y plus 1. Let's move everything away from y. I'm going to go ahead and subtract 2 to both sides. X minus 2 equals negative cube root of, this is ugly, y plus 1. Divide through by -1. This becomes negative x plus 2 equals to cube root of y plus 1. Cube both sides next to get rid of the cube root. Nice. Oh, when we did decimals, you were probably wondering where the heck did I find the equation? It's actually from here. This process of finding the inverse algebraically, it allowed me to put that into decimals a few moments ago. I just realized I didn't mention that. LOL. So my function is now negative x plus 2 to the third power minus 1 equals y. That's the equation that I put into decimals, if you're wondering. Now we're going to verify. It's kind of a pain. Let's do it, okay? I know I have fog and goff. It doesn't matter. This second equation, we'll call it as the inverse, okay? No big deal. Okay? I'm using correct notation here. So let's do the first half first, and then we'll do the second half second. Here we go. Look at the notation. It's kind of funny looking, right? This is literally fog. I just replaced g with f of negative 1. It's the same thing. Let's do the math. Here we go. The turkey, meaning what function we're substituting into, is f. Okay? The original function is, remind yourself, 2 minus the cube root of x plus 1. I'm putting in f of inverse into there right now. This is what we just got a few moments ago, okay? And then we need to simplify this, and hopefully we get this particular expression right there, x. Oh boy. This is a lot of work, isn't it? Yep, it is. I'm going to go ahead and, wow. Can't believe I did this. I'm missing something here. Oh, yeah, of course. Okay. Duh. The minus 1 and the plus 1, I just realized my error. I kind of scared myself. Those combined together be 0. Woo! Kind of scared myself. Yay. The cube root got away. A little pause there. That gives me minus that stuff underneath. Woo! Apply the negative sign. That gives me 2 plus x minus 2. And that gives me x. Woo! Big sigh of relief. Thought I messed up last year or something like that. Let's check the other way. We've got to check goff. So the first way checked out. Yay. Second way, let's reverse the roles. The turkey is the inverse, and the stuffing is what we're going to put into the original function itself. Let's do that. There we go. Negative x plus 2 cubed minus 1 is my inverse. I'm stuffing into it my original problem, 2 minus the cube root of x plus 1. Inside there, the negative sign does affect everything here and here, so let's clean that up. This becomes negative 2 plus the cube root of x plus 1 plus 2. Oh, look at that. Negative 2 plus 2 is 0, goes away. Nice. Oh, the cube root of that whole thing and the cube cancel each other out there. That leaves me with this. And ladies and gentlemen, there's my other half verification. Yay. Nice. Any questions? Okay. Let's take a look going on here. Number 5. We have some more verification. All right, number 5. We're going to use composition, Fogg and Goff, to verify that those are inverse of one another. We don't know if they are or not. If they aren't, they will not be mirror images. If they are, they will be mirror images when you graph them. Let's try Fogg first. This equals 2 f first, 1/4 of x plus 7. And the stuffing is the 4x minus 7 that goes into there. Distribute the 1/4. This equals to, what is that? X minus 7/4. Ouch. Oh, right away, this is not going to work, is it? This is not going to equal to X. Womp, 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 womp. Here, they are not inverses. That's the check there. Very good. How about the second one? Let's check Fogg first for the second one. F is the cube root of x minus 1. I'm going to put in the stuffing of x cubed plus 1 into there. Hey, that looks kind of familiar. In fact, dun, 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 dun. Well, kind of familiar to the last problem. This equals to, oh look, plus 1 minus 1 is 0. This is the cube root of x cubed. Yay, that equals x. So the first half verifies. Let's check the other half. Goff. G this time is the function, the turkey, the function x cubed plus 1. I'm going to stuff it with this piece right there. Like that. Oh, look, the cube root cancel each other out. Very nice. X minus 1 plus 1 will give me x. So that checks out as well. Yay. F of x and g of x are inverses of one another. Yay. I'm going to skip the rest of this page. Any questions about checking, verifying whether or not these things are inverses of one another? Okay, very good. I think we're ready for the last page. All right, here we go. Last page. Dun, 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 dun. Let's find the inverse for number 4. Let's do that. Ooh, very zoomed in. So don't forget, the 2 steps are swap x and y, and then isolate y. Let's do that. So we now have x equals to negative 1/2 y plus 5. Let's isolate y next and move everything away from it. Sad net. Let's subtract 5 to both sides. Very nice. And let's get rid of that coefficient in one step. Let's multiply by the reciprocal to both sides. The reciprocal, of course, is dun, 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 negative 2 over 1. The point of multiplying by the reciprocal, of course, the coefficients go away. Nice, 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 nice. Y equals to that funny mess there. Now you can go ahead and distribute the negative 2 if you want to. That's fine. Negative 2x plus 10. Yay, ding, 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 ding. And I like to replace y with the notation like this. And that's okay. Either way is fine. This is your answer right there. Any questions? Not too bad. Moving on. Oh, use composition for number 4 to determine whether the inverse of f of x is a function. We know it is, but they want us to show the actual work. Let's do that then, okay? Okay, let's do this first. And then we'll eventually do the other one. Here's my original function, negative 1/2 x plus 5. Let's put in my answer I just got a second ago as the stuffing. And let's clean it up. Distribute that negative 1/2 to everything. We're just trying to verify everything here. We get this. Ooh, negative 1/2 times negative 2 is positive 1x. Negative 1/2 times 10 is minus 5. And there it is, yay. There's my verification. We know it should work, right? If we did our algebra earlier, it should work. And let's do the inverse. This is just extra work, by the way. This time my inverse is the turkey, negative 2x plus 10. We're going to stuff it with the original function, negative 1/2 x plus 5. Go ahead and distribute the negative 2. And I get, in this case, 1x again. In this case, minus 10 plus 10. Yay, that gives me x again. And we know that this would work. So there's my process of proving that these are inverses of one another. Whew, almost done. Oh, we want to sketch the graph of that. Okay, fine. Because I have a 10 and a 5, I'm going to have to go by a scale of 2, I believe, and I'll do that. Here are my original functions, just for reference here, because my screen has been moved up, and here's my inverse. And when we graph them, we should get a mirror image for both of them, right? Okay. We're going by 2's, by the way. All right. First one is negative 1/2 x plus 5. Y-intercept is 5. 5, 2, 4, 5. 1/2. Down 1 over 2. Down 1 over 2. Okay. There's the first one. My original function. And the second one has a y-intercept of 10 all the way up there. Its slope is negative 2 over 1. There's that one. Crazy. And are they a mirror image of y equals x? They certainly are. Yay. Woohoo. How can you verify by the graph of f and its inverse by the graph now? Well, it's a mirror image. I mentioned along the y equals x line. Sweet. I think we have one more question. Is the inverse of f of x a function explained? Yes. Is the inverse a function? Now I kind of jumped the gun and said yes. We want to, it passes the vertical line test. Remember, every x value has a unique y value. If I scroll back up a little bit, my red function will pass the vertical line test no matter how many vertical lines I draw through there, it will only hit it once. So the inverse of the function is also a function. Okay? The inverse of a function is also a function. Well, thank you very much. That's it for me. Thank you for being patient. See you next time. Bye-bye.